Okay, so in the last video, you started by solving fractional equations, and we're going to kind of continue with that. So if you look at number 33 in your packet, so if you want to stop me for a second, grab your packet and turn to number 33. All right, so if we look at this, what we're going to try to do, just like we did with the last video, is we're going to find a common denominator. So I'm going to start by putting that 1 on the right side of the equal sign over a 1. So now if I look at all four denominators, I see that what I have here is I have a binomial y minus 1, and then I have a monomial y. Okay? Now this binomial y minus 1 is obviously the same as this binomial y minus 1. Please remember that this y in that y minus 1 is not the same as this monomial y. So when we're trying to find a common denominator, then what we want to make sure that we do is represent both the monomial y and the binomial y minus 1. So this first denominator, we're going to multiply by y. And remember, what we do to the denominator, we also have to do to the numerator. Okay, so then this denominator here, we're going to multiply it by the binomial y minus 1. Because now you can see that matches the denominator of the first fraction. And what we do to the bottom, we do to the top. Okay? So now, again, just let me kind of point out here. Do you see this denominator here matches this denominator here? Okay, so we're trying to go for that common denominator. All right, now we're going to take the third fraction and we're going to multiply it top and bottom by y. And the last fraction is missing everything. So we're going to multiply that by a y and a y minus 1. Okay, both numerator and denominator. Now, if you look at your steps that are up at the top of the page, you will see that it says find a common denominator. So we just did that. Now, step 2 says cross off the denominators. So I'm simply going to go through here and I'm going to cross off all the denominators because now we have a common denominator. Then it says solve the remaining numerators. That's step 3. So what I'm going to do is I'm going to kind of combine like terms here. So my y times my y will give me y squared minus 8 times that y minus 1. I'll distribute that in a minute. I just kind of like to write it all down first. Plus, and then y times 1 is just y, equals. Now, if you look over here, I have 1 times y. So that's, I'm going to write that just as y. And then I will distribute after. I think it'll just be a little bit easier to just write it down first. So I'm going to write y times y minus 1. All right, so now let me go through and do all the distributing. So I have y squared minus 8y. Remember, that's going to be a plus 8 because we're distributing the negative 8 through. Plus y equals y squared minus y. All right, well, I've got a y squared on the left and a y squared on the right, so I know those cancel out. Let's combine like terms on the left, and that's negative 7y plus 8 equals negative y. I'm going to add that 7y to both sides of the equal sign. And that's going to give me 8 equals 6y. And then from there, I'm going to divide out my 6, and I will get y equals 4/3. There we go. Now, as in the last video, you should always check your answer to make sure that we don't have extraneous roots. So in other words, this 4/3 right here, if you plug it back into any of the denominators of the original equation, so let's go up here, y minus 1 was the original denominator here. If I do 4/3 minus 1, I will not get 0. So my denominator is not undefined, so that's okay. So now I'm going to take this 4/3 again and I'm going to plug it into this second original denominator, which is right here. And if I plug in a 4/3 here, I don't get 0 in the denominator, so we're okay. Let's go over to the third denominator. This was the original denominator, y minus 1. And if I plug in 4/3 here minus a 1, I don't get 0. So again, we're okay. And then this one, well, technically the denominator is 1, and I can't plug in 4/3 here. So as long as when I plug in my solution here, and I don't get an undefined fraction in any part of the original equation, then we're good to go here. So we are good to go. We have no extraneous roots. All right, so why don't we start again with step 1 if you look at the first page, and that says to find a common denominator. So why don't you turn the page, and we're going to go to number 37. So before I find a common denominator, what I would actually like to do first is just take this and let's factor that. And I'm going to do AM. So what adds to a -1 and multiplies to -12. So that would be x minus 4 and x plus 3. And what that allows me to do is I can see the common denominator a lot better, I think. All right, so now I see that the first fraction is missing an x plus 3. So I'm going to take that first fraction and I'm going to multiply it by x plus 3 in both the numerator and the denominator. The second fraction, I'm going to multiply that by x minus 4. Again, both in the numerator and the denominator. Now the third fraction, look at the denominator there. That denominator already has everything we need, so we don't need to multiply that last fraction by anything. All right, so then why don't we just go ahead and let's go to the next step. And if you look, the next step says to cancel out the denominators. So we have a common denominator, so I'm just going to cross all of those out. And let's rewrite that numerator. So I'm going to have x times x plus 3, I'll distribute later, minus, now I have a 1 times an x minus 4, so I'm just going to leave it like this, x minus 4. And the reason why I'm leaving this in parentheses is I need to be very careful of this negative sign here, or this minus sign, because I'm going to have to distribute that negative to both terms. So that's why I'm just going to kind of hold off with that right now, in distributing, I mean. Okay, equals 28. All right, so let's now go ahead and distribute. So I'm going to get x squared plus 3x. Now here's where we want to be a little careful. We're going to get minus x, and then we're going to get plus 4 equals 28. All right, now I do see that I only have one term with an x squared, and that is my highest exponent in this entire equation. So I have a quadratic here, which then is kind of make me think that maybe I should factor or maybe do the quadratic formula or something like that. So I'm going to get everything over to one side and set it equal to 0. So I'm going to move that 28 over to the left while I'm at it. So I'm going to get x squared here. Now I'm going to add my plus 3x and my minus x, so that's going to give me plus 2x. And then I'm going to subtract that 28 on over, so that's going to be minus 24 equals 0. All right, well, my lead coefficient is a 1. So maybe what I want to consider thinking about is how about if I just figure out what adds to 2 and would multiply to a negative 24. So if I think about that for a second, I would say, oh, well, I got 6 and 4. So let's try 6 and 4. So that would give me x plus 6, right? And that would give me, what, x minus 4? Okay. Now I'm trying to solve, so I'm going to do my little t-chart here. And I'm going to do x plus 6 equals 0, and x minus 4 equals 0. So over here, I'm going to get x equals negative 6, and over here, I'm going to get x equals positive 4. Now, let's be careful here, because we do need to check to make sure that neither of these answers are extraneous roots. So I'm going to start with my answer here on the left, which is x equals negative 6. Now remember, an extraneous root means if I plug this value back into the original equation and it makes any of my denominators undefined, in other words, equals 0, then I have to reject it and say that it's an extraneous root. So let's throw negative 6 into right here. This was the original denominator. Okay, so negative 6 minus 4 does not give me 0. So we're okay so far. Let's go over here to my second denominator here. Okay, and if I plug in a negative 6 here, I do not get 0. So I'm okay. And then over here, I could plug in negative 6 here and work it out. Or I can plug in negative 6 in here because it is equivalent. And you'll see that I'm not going to get 0. So in that case, negative 6 is fine. However, let's check out 4 here for a minute. Because if I plug in 4, let's go up here. If I plug in 4 right here, don't I get 0? Now it doesn't matter that if I plug in 4 here, I don't get 0. If you plug in 4 in any one of these 3 denominators and you get 0, then it's considered an extraneous root. So in this case then, x equals negative 6 is our solution, and x equals 4 rather is not, because it's an extraneous root. Got it? All right. Okay, so we're going to move on to the word problem. So if you want to turn the page, we're going to look at number 39. If you would take a second and you can turn me off and read the question. All right, so when we look at a question like this, and you'll see that number 40 is going to be the same as well, and so is number 41, and so is number 42. When you have a question like this, what you try to do is we're going to set up a fractional equation. So if you read, it says that all 3 of them together can paint the room in 2 hours. So what we want to try to do is think of it in terms of 1 hour. How much of the room rather will they have painted in 1 hour? So if in 2 hours they can paint the entire room, all 3 of them together, okay, so in 2 hours they can paint the entire room, then in 1 hour they're only going to get through half of the room. Follow? So when Sam's working alone, I'm reading the second sentence there, he can paint the room in 6 hours. So for Sam, I'm going to put S for Sam. So for Sam, in 1 hour, he's only painting 1/6 of the room. Okay? And when Jenna works alone, I'm reading the third sentence, she can paint 1 room in 4 hours. So for Jenna, if she can paint the room in 4 hours, in 1 hour, she's doing 1/4 of the job. And then the question's asking, determine how long it would take Francisco to paint 1 room. Well, we don't know, right? And when we don't know something, we call it x, don't we? But we would say 1/x, because if it takes x hours for him to paint a room, then in 1 hour it would be 1 divided by x. So then all of these together, aka add, would give us how long it takes them to paint the room. Well, it takes them 2 hours, all 3 of them together, right? It takes them 2 hours to paint 1 room. So then in 1 hour, they will have painted half of the room. Okay, a little trick, another, cheater shortcut is you can take whatever their time is and just put it under 1. Okay, so it takes, if you want to think of it from this perspective, so it takes Sam 6 hours, so 1/6. It takes, who was it again, Jenna? Yeah, Jenna 4 hours, so 1/4. It takes Francisco X hours, so 1/x. Altogether, it takes them 2 hours, so 1/2. I don't know if you just kind of want to go with that thought. That might work better for you. Now listen, at this point, everything else is going to be exactly what we were doing with all the other questions. So at this point, we're just going to find a common denominator. So we have we have a denominator of 6, 4, x, and 2. So I'm thinking 12x. So then that means that this first denominator needs a 2 and an x. So does the numerator then. The second denominator then would need a 3 and an x. So would the numerator then. Okay, the last fraction to the left of the equal sign would need a 12. And then this one over here would need a 6x and a 6x, right? Okay, so we found a common denominator. Now, same rules as what you were doing with all the other questions. So once you get your common denominator, go back to the very beginning of the packet. First rule, find a common denominator. Second step, cross out your denominators. All right, so then here we go. So we're just going to get 2x plus 3x plus 12 equals 6x. Really not so bad, right? Now we're just going to solve the numerator. So we get 5x plus 12 equals 6x. I'm going to move that 5x over. And there we go. 12 equals x. Now let's just go back and figure out what those units are. Determine how long it would take. Well, this was in terms of hours, so 12 hours. And there's your answer. Okay, so honestly, once you get the setup, the rest of it's really pretty straightforward. So like I said, number 40 is going to be the same exact way. And so is number 41, and so is number 42. So what I'm going to ask you to do, if you still have time before the end of the period, I would like you to just try number 40, and then tomorrow when I see you, I will go through any questions that you have on any of the fractional equations on either video. Also 39 or 40, the word problems, if you have any questions. But tomorrow we will continue with these word problems. So with the remaining time, then what you can do right now is you can start your review sheet, or you can get on Castle Learning and you can do your bonus points for your test. Okay, I'll see you guys tomorrow.